Good morning, guys. So, in our last session, we discussed about Route 53. So, any questions on previous session? No questions, all good. Okay, so then here in today's session, we are going to discuss what exactly VPC is. So, when coming to this VPC, VPC stands for Virtual Private Cloud. VPC stands for Virtual Private Cloud. So, this is an isolated network or environment for a project. So, or you can treat it as a data center within our AWS environment for a particular project, right? By defaultly, every single region will contains a default VPC. Every region contains default VPC, right? So far we have used the default VPC, but generally in our organizational environment, so we are not going to use this default VPC most of the times. So the reason is this default VPC is a user friendly. So it's ready with all the all subnets as a public facing subnets. So that means whatever the instance we're going to launch, it's going to be accessible over the internet. So we have some web server that contains some critical data, right? So that contains some critical data, and also making that such type of web servers or database servers as a public facing is not a secured option. So to overcome that, like we got a concept called public subnet, private subnet concept. So those all are we will discuss right in detail. But whenever we are launching anything in default VPC, all subnets are public facing subnets only. So whatever the thing you are going to run here, you can access anywhere from the world if you are opening that required port in security group. But VPC level, everything is opened. Right. So that is a first thing. Now let's try to understand the IP addresses. So when coming to these IP addresses, so we have IPv4 and we have IPv6. Right. We have IPv4 and we have IPv6. When coming to this IPv4, it is a 32-bit. Right. When coming to IPv6, it is a 128-bit. Right, we are going to get 4.3 billion addresses with IPv4, and we are going to get 2 to the power 128 number of IP addresses. So let me write down that. I have a slide for this. I'll share you that. IPv4. So IPv4, it's a 32-bit. So that means we are going to get 2 to the power. So for power symbol, I'm using this cap symbol. So this cap technically represents as a power. So whenever you are giving 2 to the power 32, whenever you are giving 2 to the power 32, so this is a value, right? So these many IP addresses we are going to get whenever you are using IPv4. But IPv6 is a 128 bit. So here we are going to get 2 to the power 128 IP addresses we are going to get. 2 to the power 128. So these many IP addresses we are going to get. Right. So we are going to discuss this VPC with IPv4. IPv6 is it's a completely a different concept. And from 2010 onwards, they are saying every organization is going to start using IPv6 and all. So still many organizations are using IPv4. Even in my current project also, for every single network, we are using IPv4 only. I'll log in and I'll show you. So some real environment, for this VPC also. So there you can observe which one we are using and all. right? So I'm going to explain it with IPv4. So within this IPv4, again, we have some classes. So we have class A, class B, C, D, and E, right? So based on our requirement, we need to choose one class. So when coming to this class A in IPv4, we have class A. So in class A, it starts from 0.0.0.0 to 126 dot, or technically it is a 127, but 127 treated as a loopback IP address. So 127.255.255, but as I mentioned, 127 refers to loopback IP addresses, so it's 0 to 126, and 128 to 191. So then when coming to class C, 192 to 223.255.255.255. Okay, so when coming to class D and one class E, so these we are not allowed to use, like, this is not for public usage. This is not for public usage. So according to some articles I've seen, like, NASA actually uses these classes and all. Oh, it's a one second. Let me. It's 128 to 170 only. Think I missed that. Yeah, this is a one. So 191, 192 to 223. So 224 to 224 to. So then 239. So 242, 255, 254. So 255 actually. So 127 is a loopback, and 255 is a broadcast IP address range. So these two we are not going to use. So 127 series we cannot be used, as that is a loopback IP addresses. So generally take any IP address, even this first one also, technically it is going to start from 1 dot. Technically it starts from 0, but actual value it starts from 1. Why? Because 0.0, basically 0 is a network ID, 255 is a broadcast ID, 127 is a loopback IP address. So these three we are not allowed to use. Again, can we simply go and use any of these ranges? So the answer is no. So basically, based on how many IP addresses we required, based on that, we are going to choose this. So for example, so in what scenario that service provider or we are going to use this class A IP addresses. So if we required more hosts and less networks, then we can go with the class A. Forget about these two, class D and class E. Forget about this class D and class E. So when coming to this class A, so with this class A, we are going to get 127 networks. Why? Because it's like, 0 to 126. Let me mark it as 0. So from 0 to 126, total 127 networks we can create. So why, when coming to class A, first one represents as the network, remaining represents as a host. When coming to class B, First two represents as a network, remaining two represents as a host. When coming to class C, first one represents as a first three represents as a network, last one represents as a host. So simple, how many networks you required and how many hosts the network is going to contain. Network means group of interconnected devices, that we can call it as a network. Group of interconnected device. For example, you have a Wi-Fi network in your home, right? So that is a network. Your Wi-Fi, for example, in my case, this Avisway is my network. Within that network, how many devices, how many laptops or mobile phones or printer or desktop got connected to that particular network? Those all devices, we are going to call it as a host. So if you required less network, but every network required more number of hosts, then we are good to choose with the class A IP address range. With this class A IP address range, we are going to get 127 networks, and each network contains 16 million hosts. So out of this 127, one dot network will give 16 million hosts, two dot network will give 16 million hosts. Similarly, we can create 127 network, and each network will give us 16 million hosts. When coming to this class B, so here we are going to get 16,000 networks. We are going to get 16,000 networks, and each network contains 65,000 hosts. Each network contains 65,000 hosts. Again, that based on our requirement only. When coming to this class C, so more networks, less host here. So every network will support only 256 hosts, but technically -2. This first one and last one we cannot use in any network. Take any network. So that I will tell you. So how many we can create? 2 million networks, and each network contains 254 hosts. So technically it's a 256 minus 2. Minus 2. Why minus 2? Take any network. So first one is a network ID, last one is a broadcast ID. Those two we are not allowed to use for that purpose. Right. So this is multicasting purpose. So we really don't know, and it is not for public usage. You cannot use that. And the last one is for future usage or for R&D purpose. As per some articles, NASA uses these particular IP ranges. So that there is no particular source for that. Right. These are the classes we have. So how we are going to get these classes? For example, let's take one as an example. So I'm going to take, see, in your home, like you might notice whenever you go to command prompt, if you are giving ipconfig, it is going to show you an IP address 192.168.0.138. So it's a 192.168.0.138. What class IP address it is? Okay, so it comes under class C as it is starting with 192. Right. So as it is a class C, first three represents the network, last one represents the host. So this is my network ID. So in my entire home network, even my Wi-Fi device. So if I'm giving 192.168, 192.168, 0 is a network. One, the first one I have allocated to my router. See, 192.168.0.1. So then it is allowing me to log into my Wi-Fi router. So then any other device. So if you want to see how many devices you got in your network, you can use some tools like, IP scanner or Angry IP scanner. Angry IP scanner is a tool I use much. So you can just go here and I'm just downloading an executable one. So this is a Angry IP scanner. I just downloaded that to my local machine. Come on. Did I download it spam? Only verified apps I need to install. Come on. So it tells us what is the network and how many devices got connected to this particular network. We have, this is also device. Yeah, this is the one. It got installed here. So now, what is my network ID? 192.168.0.0 is my network. So what are the possible range for that 192.168.0.0 to 0.255? So now click on start. It is going to check each and every device. See what is the host name, what is the ping status. Say 192.168.0.1. I'm able to get the reply. Okay, similarly, how many IP addresses is consumed? For example, 192.168.0.157. It is consumed by one application. Total 6 hosts alive in this particular network. 0.173 is used, right? So 0.138, this particular device 0.140, 0.130. So these all are used within this. So as I'm using this class C IP address range, just observe here. First 3 is a fixed. 192.168.0 is fixed. So that's a network ID. The last one, 130 is for one host, 138 is for another host. I don't know. 0.140, that is for some device. So, some advanced tools will give that if it is a printer or any network or phone, everything it is going to give here, right? So this is a network and host mechanism. I hope that is clear, the network and host mechanism. So we can create 250, we can see here this value is changing to 0 to 255. 192.168.0 is fixed, if you observe this. But the last value is changing, and from where to where? From 1 to 254. So that means technically 254 we are going to get. So 0 and 255 is not mentioned, but it is also part of that. So we are going to get 254 hosts for one network. This is one network. Now I want to create another network. 192.168, 1 dot, another network. 2 dot, another network. 3 dot. So first 3 we can change in 2 million ways. And every network is going to give only last one we can change 0 to 255 or 1 to 254 also you can read. Technically it's 0 to 255. So when coming to this class B IP address range, so when coming to class B, let's take 128.128.0.0.0. Now first 2 is going to be fixed. That represents a network. And how many hosts? Here 0 to 256 and here also 0 to 256. So for this particular network 128.0 is fixed. That is one network. Then these two, how many ways we can shuffle or we can generate? 65,000 ways we can shuffle here in one single network. How many ways we can shuffle? 16,000. So that is a class B IP address range. So based on our requirement, we are going to choose. AWS gives class B IP address range by defaultly in all the for all the default VPCs. When coming to our custom one, we can choose any of the one. Again, are we allowed to use all these ranges? No, we are not allowed to use all these ranges. So we have a concept called public IP address and private IP address. For every single network, we have a private IP address. So based on our requirement and how many you required, based on that, you need to choose one of the private IP address range. So when coming to public IP address, this is unique across the globe. When coming to private IP address, this is unique within the network. So I'll give you a very simple example for this, guys. So for example, this public IP address is Avinash Reddy Tipparthi. So this is a public example for public IP address. When coming to private IP address, so Chinna, Kanna, Bujji, whatever it is. So this is a private IP address. So who is going to call me with this name? Only my family members are going to call me with this name. Right. So again, for example, they are calling me with the name called Chinna. My brother is there. Are they going to call him also with the same name? No, right? The conflict should not happen within the network. But the name we are using within the network only, within the family only. For example, I have a name called Chinna. So in your family also, you might have one Chinna, right? But this one is a unique. There is an organization who maintains all this uniqueness of this public IP addresses. So if I already took this name, nobody should have this name. For example, someone want to call me from somewhere over the world. So then they are going to use this public IP address. The uniqueness come to our EC2 instance or for our application, right? That comes by using this public IP address only. This private IP address, no. So to use this, we need to get a public IP address from ISP and they are going to cost us. See, in your home, you are going to take internet line, right? You are going to take internet line from ACK FiberNet or like, some of the service providers. So they are going to give you a public IP address. So how to know your public IP address? Go to browser, give my IP in the Google, it will show, see, this is my public IP address. So across the globe, this is my public IP address. No network is going to have this. See, if I perform any cyber crime or if I perform anything, directly they will come to my network. Why? Because this is allocated to my network. So in your organization also, this is going to be fixed for your network. Fine. What about this private IP address? So this private IP address, it's within the network we are going to use. So whenever we open command prompt, what are the series we are getting? 192.168.0.138. So this one, it is not a unique one, but within my network, yes, it's a unique one. So in your home also you can use. So that is a private IP concept. So if you are taking these classes, every single class, its own private IP address. If you are taking class A, 10 series. If you are taking class B, 172 series. If you are taking class C, 192 series. So these are the ones, private IP addresses of our networks. So for using this, you don't need to pay anything. No one is going to cost you. These are the private IP addresses. So we are going to choose only one of these, nothing more than that. But you must remember these. Again, what mechanism? How you are going to choose class A? How many you required? What is a mechanism to choose class B? How many you required? Class C. Same mechanism here. Okay. Remaining all except this 10, 172, 192. Apart from these three series, remaining all are public IP addresses. If you find an IP address with 3 dot series, it comes under class A, but it is a public IP address. Whenever you see 10, 172 or 192, okay, this is a private IP address, right? That should come into your mind. Even while creating our VPC also, we are going to choose one of these private IP ranges. You are not allowed to use remaining any of the range. That is a mechanism. Now, I am open to your questions. So whatever the topic we discussed so far, if you have any questions, we will discuss now.
You said the default VPC has a public IP range, that public IP address?
See, whenever we are launching an EC2 instance, we are getting a public IP address. So AWS will give the public IP address. For public IP addresses, there is no particular range. Apart from these three series, remaining all are public IP addresses only. Yes, we will get a public IP address for our default VPC also. By using that only, we connected to our EC2 instances so far. While connecting to our EC2 instance, which IP address we used? Is this private IP address we used? No, right? We used public IP address that AWS gave said public IP address. I hope I answered your question.
Yep, thanks. Could you, like, are you going to cover static IP in addition to this, or like, how does static IP play out in all of this?
You mean DHCP and static IP address you are talking about, or?
Yeah, DHCP and static IP.
Okay,
yeah.
I'll talk about that. So if you don't know what is IP address or networking concept, only thing you need to understand is what is public IP address, private IP address. What are the classes, these ranges you must remember. Okay, I'll give you a visual subnet calculator. By taking that only, we are going to segregate this entire CIDR block to different subnets. Okay, so now when coming to certification point of view, we are going to get a question that related to subnet. So again, I am going to give a high level overview about the subnet, not deep dive and not going to perform like, subnet calculations and all. So when coming to this, I told you one thing that IPv4 is a 32-bit operating, a 32-bit one. So that means we are going to get 2 to the power 32 IP addresses. How we are going to get? I'll try to explain you the logic or mechanism. Okay. So basically, if you're taking IP address, it contains 4 parts. So if you segregate that, or if you deep dive into that, every IP address or every segment have 8 bits. So those 8 bits we can fill with either 0 or 1. So let's take 1 first. 1, 2, 3, 4, 5, 7. Total 8. So now similarly we are going to have like total 4 parts. So if it is giving /32, so 8 total 8 bits and 4 parts, right? So 4 into 8, 32. So total 32 empty slots are there. Out of the 32 empty slots, So, whatever the one you are giving /32, out of 32, 32 got filled. Whatever, if you are giving /30, that means, okay, out of 32 slots, 30 slots full. How many slots empty? 2. How many ways we can fill up with zeros and ones? That is important here. So now, out of 32, I'm giving /32. That means all the 32 slots are full. So how many ways we can fill? Only one way. But you have given /31. So that means all blocks are full. All blocks are full. Only one block is empty. So that's what it means, 31/31. So out of 32, he is giving /31 minus 31. So how many, what is the value? 1. So within this one slot, by using either 0 or 1, how many ways we can fill? You can add either 0, that is one way, or 1, that is two way. So whenever you are using /31, 2 IP addresses or 2 slots we are going to get. So that is. So when coming to, you are given /30. So that means /30 means 2 slots are empty here. So these 2 slots, remaining all are full. Whenever you are giving /30, 2 slots are empty. Now, so by using 0 and 1, how many ways we can fill? 0, 0, 0, 1, 1, 0, 1, 1. So if you are using /30, in 4 ways we can fill. So that means technically 4 IP addresses we are going to get whenever we are using this /30 subnet. /31 subnet, we are going to get 2 IP addresses. Whenever you are using /32, 1 IP address we are going to get. So similarly, when all slots are full, that means /0. So total 32, nothing is full. That means 2 to the power 32 ways we can fill. So that is the logic. So now let me write down that here. And always -2, I'll tell you that. So 2 to the power. So /32 means 2 to the power 0 /31 /30 /29 /28 /27 /26 25 24 /16. In between we have, but I'm not going to write everything here. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 16, 2 to the power 32. So now, so whenever you are using /32, out of 32 slots total, just remember total 32 bit and treat it as a 32 slots. Out of 32 slots, 32 full. So only one way we can fill that. Only one we are going to get. Now out of 32 slots, 31 dot full, and so by using 0 and 1, how many ways we can fill the empty slots? So by using 0 and 1, so 32 minus 31. So one empty slot is there. How many ways we can fill? Either you can put 0 or either you can add 0 or 1. So 2 ways. So 4, 8, 16, 32, 64, 128, 256, 65,536 and some 4 million IP addresses. This is a logic. And by defaultly, as I mentioned, every network defaultly reserves IP addresses. But in AWS, AWS reserve 5 IPs along with these two. These two, network ID and broadcast ID. The first one 0 and 255. These two, not only here, anywhere you cannot use that. Okay, along with that, Amazon is going to reserve two more IP addresses for DNS. One is for future use. So two IP addresses for network ID, and broadcast ID. Okay, so two AWS reserved for DNS servers and one is for future use. So AWS reserves total 5 IP addresses and AWS supports /28 to /16. AWS supports /28 to /16. The maximum EC2 instances you can launch in a VPC is 65,531 IP addresses. Why? Because -5. Okay. So minimum is a /28. So that means how many? We are going to get 16. Right. So we are going to get 16 again -5. So total 11 usable IP addresses. If you are using /16, 65,531 usable IP addresses. Total IP address we are going to get these many, but -5. Why -5? As AWS is reserving these 5. So /28 is a minimum VPC size we can define. So /28. So how many IP addresses? 16 it is going to get -5. So that means 11 usable IPs. For example, you are using /24. As you are using /24, 256 IP addresses we are going to get -5. So then 251 usable IPs we are going to get. Whenever you're taking the maximum one. So maximum VPC size is this. So as it is /16, how many? 65,536 -5. So 65,531 usable IPs we are going to get. So in your exam, you can definitely expect this, or in your in your organization in technical discussions also, this is important. So which one you're going to take based on your requirement, you need to pick. And one more thing, we are going to call this as t-shirt size. So initially, around 3 years or 4 years back, we were in discussion with one of the client and he asked us, so what t-shirt size you suggest to network? I was shocked. Okay, what is this t-shirt size? So basically t-shirt size is nothing but the network size. In VPC, in your technical discussion, if someone try to showcase their such type of things, or if they will try to test you how familiar you are with this this such type of terminologies, we are going to call server as a box is nothing but a server. Box is nothing but a server, right? So similarly, so if they are pointing something t-shirt size of network is nothing but how big is your network. In simple, what is the subnet, whether you're using /32 or /16. So this one we call it as a CIDR also. CIDR stands for classless inter domain routing. CIDR range is nothing but VPC range. So these are some terminologies you must remember. T-shirt size or t-shirt size of network. That means how big is your environment is, how many IP addresses you are going to have for that VPC and all. So sometimes they call same thing. Whatever the question they are asking, same thing. They might ask you, what is the CIDR range of your VPC? The CIDR range of VPC is nothing but what class you are using, what range you picked. So one of from these three we need to pick, right? That one you need to mention. So they are not going to call it as a CIDR, they call it as a cider range or t-shirt size, right? Mainly white people use more such type of terminologies. Not Indian people, but white people definitely they use such type of terminology. Okay, so I hope this part is clear. And if you got a question like, you need um, you need 64, right? 64. So you need 30 IP addresses per your network. You are designing a VPC, you assuming that you need to launch 30 EC2 instances within that VPC. What is the minimum CIDR block you are going to choose, or what is the minimum subnet you are going to choose? Which one you are going to choose among this?
/27.
Wrong.
Okay, sorry, +5 /26 because 5 we cannot use. Yeah.
Yes.
Yeah.
That's the logic. That's why I raised that question.
Yeah.
So you must do -5 from this output. So I got this question in exam. I wrote this same. So I calculated. So you got, no, this is the logic. So in simple, total 32. What cider block is using? Okay, is giving /24. So total 32 minus 24. What is the value? Give that value as a 2 to the power. Then you will get that value. So here 32 minus 24. Minus 24. We are going to get 8. So here 6. How many? 32 minus 24. 8, right? So now do 2 to the power 8.
3.
So then what is the value you are going to get? Those many IP addresses you are going to get. So as it is a 2 to the power 8, so that means 256. So 256 minus 2. When coming to AWS, -5. So this is a calculation we need to do. Right. So now when coming to VPC, within VPC, we have a concept called public subnet and private subnet. When coming to this public subnet, whatever the instances you are going to launch in this public subnet, those instances are public facing ones. So technically these resources we can access anywhere from the world if you have valid credentials. We can access these resources anywhere from the world as it is internet facing. Okay, when coming to private subnet, we can't access over the internet, but we can access within the network. Again, how to get connected to the network? For that, we are going to use a mechanism called jump server. I'll show you hands-on in our tomorrow session. But private subnet means we cannot access over the internet or non-internet facing resources. For example, you have a database instance, RDS instance is there. So that contains some sensitive information like credit card information, debit card information. So some sensitive information is there. So such type of sensitive information, if you're facing directly, you're making it as a public facing one, then hacker, he can get connected to that and he can access that, right? But when coming to private subnet, so whenever you are running this RDS instance in private subnet, so it's not going to be internet facing one. But how we can get connected, that we will see. But if you want to get connected or if you want to access that, so we need to depend on like, different mechanisms, right? So that's a very high level overview, but we are going to perform that hands-on. Don't worry about that at the moment. If you still have any questions on this, I'll definitely take your questions in our tomorrow session, not now, right? So when coming to this VPC creation have couple of steps. First thing, how big your VPC should be. First thing. Second thing, how many subnets? Okay, how many subnets you required, and out of that, how many public subnets you required, how many private subnets you required. So let's keep that concept aside. So you are constructing a building. Let's take this VPC as a building construction. So you are constructing a building. So as you are constructing a building, one question: how many floors you required? How many floors you are going to construct or you required? Okay, I need 2 floors. So this is floor 1 and floor 2. Now, what is your total building capacity? For example, this building can support 10,000 members. This building can support 10,000 members. That is total building capacity. Okay, out of the 10,000, what is the capacity of this first floor or what is the capacity of the second floor? So if you are giving this entire capacity to this, do we have anything left here? Entire building capacity is 10,000 and you are giving that entire capacity to floor 1 only. So do we have anything to floor 2? No, right? So we are not going to give in such type of manner. Okay. Total capacity is 10,000. 4,000 I am going to give here. 4,000 I am going to give here. Remaining 2,000 I am going to keep it for future usage. If I construct any other one, so I can place 2,000 or I can place 1,000 and all, right? So similarly, when coming to VPC creation, for entire VPC, what CIDR block you want to give? For this entire VPC, what CIDR block you want to give? So most of the times, we are going to choose the maximum one. Okay, I want to pick /16 here for this VPC. What is the advantage if you are picking /16? So you are taking the maximum one. Now, this is subnet. This is subnet 1. This is subnet 2. Now, if I want to give this entire /16 to this only, we can, of course, we can allocate. But do we have anything left for this? No, right? Total 65,000 IP addresses you are going to get. Those 65,000 IP addresses you have allocated here. So anything do we left here to allocate? No, right? So that's why we are not going to give in that manner. So now you want to give /17 here, /17 here. Now, how many you are going to get? 65,530, 32,000 change here, 32,000 change here. So total we are consuming. But do we have anything left for future usage? No, right? So that /17 also most of the times we don't use. The commonly used one is /24 is a commonly used one. Of course, if you want to use /20, you can use it. Anything below to this /16 we can use. Anything between /28 to /16 we can use. But if you are giving /16, it is going to consume everything. So we don't give that directly, but remaining all we can allocate here. So for example, you given /24 here, /24 here. So 251, 251. So out of that 65,000, 250, 250, 65,530, you have consumed only 500. Remaining 65,000 for a future usage. If you create another subnet, yes, you can allocate there. So this is a comparison. And how you're going to choose, like, whether /24, /16 and all. For that, we have a visual subnet calculator. So navigate to Google, look for visual subnet calculator. Go to this. Now, among these ranges, which range you want to use? Okay, I want to use 192.168.0.0. Copy that, give that here. Now, what is the VPC subnet you want to give? So most of the times we go with the highest one. So /16. So navigate here, give /16. Now click on update. Now, so you want to go with the usable IP addresses? Yes. So now uncheck this. It shows all the IP addresses, or else go with this. Now, how many 65,534 IP addresses? 536 minus 2 only it is going to show, but in our case minus 5, right? So let's keep it. So now, how many subnets you want to divide here? This is my entire VPC. I have mentioned that here. Entire VPC mentioned that here. Now, how many subnets you want to create? So I need 4 subnets. So then this /16 is there, right? Divide. Whenever you divide 32,766, 32,766. So now copy this, give it to one subnet. Where is that? Copy this, give it to another subnet. But do we left anything for future usage? No, right? So we are segregating this /16 to /17 and /17. So now I don't need 32,000 IP addresses for my VPC, for my subnet. Divide. See? So even /28 is the minimum one, right? VPC supports /28. So how many /28 ones you required? For example, you required /28 ones. So see here, these are the 4 you can use. It comes under this 192.168.0.0. If you want to join, of course, you can join that. These 2. So based on this subnet calculation, first, how many subnets you required? For example, I need 4 subnets. Take this 4. Every subnet is going to give 16,382. So for spare, I want to keep 1. Okay. Take this IP address. So now every subnet is going to give 8,000. So copy this, give for subnet 1, give this to subnet 2, give this to subnet 3, give this to subnet 4. The remaining 4 is for future usage. Of course, even in future, you decided to create small networks, divide it again. So based on your requirement, how small you want to create, how big you want to create, you can use this visual subnet calculator. So you got this mechanism, guys?
Yes.
Right. So again, remember here it is only -2. Why? Because it is not pointed to particular AWS, but we need to calculate -5. So if you observe our default VPC, let's navigate to default VPC. Let's try to understand. So this is my default VPC. Navigate to VPC. So what series they have used? 192.172.31.0.0/16. Given that here. Now click on update. Okay, or just reset. So now this is the one 172.31.0.0. So how many 65,534 we are getting as we are using /16? How many subnets we have? So these are the 3 subnets. So every subnet contains /20/20/20. Okay. So here when /20 comes, /17 only, /18, /19. Now /20s are coming. So these all are /20 IP addresses. What AWS did, among these, they have picked three. That is 16.0, 32.0, 0.0. 0.0, 16.0, 32.0. So the first three, whatever the one AWS given first three, they took these three IP addresses. Remaining all are still available. As they took /16 65,000, we are going to get how many we used? 4,000, 4,000, 4,000. So if you scroll down to right here, you can see 4091. See here it is showing 4094, but minus 3, right? Total minus 5. 4091, 4091, 4091. That we are using for our existing VPC subnets. The logic is same. Same logic we are going to use here. What is the range you required? Then divide how many you required. That I am going to ask you how many we required and all. You tell me a value. Based on that value only I can configure our VPC. So that is a logic. One is entire billing capacity. Another one is individual floor capacity. If you have any thought for future usage, you definitely keep some in available state. That is a logic here. Now, when coming to this, so first we are going to create a VPC. Within that, we are going to create a subnet. So then we required internet connectivity for this subnet. So that internet connectivity we are going to get by using a component called internet gateway. After placing this internet gateway, to what subnet this internet gateway communication required, that we are going to perform subnet association. That's it. So VPC main primary component creation just involved with 5 steps, guys. Nothing more than that. It's just a 5-step process. Okay. So if you are understanding that 5-step, you are too good with this VPC. That we will discuss tomorrow. But I'll before closing the session, we have an option called VPC dashboard. So we have VPC Wizard, launch VPC Wizard. Whenever you click on that, some pre-templates, like VPC with a single public subnet. Public subnet means it's accessible over the internet. Okay. So click on select. What is the CIDR block range you want to? Okay. I'm going to pick that entire one and I have given that here. Update. Now. So this is a one we got. So now within this, how many subnets? Only one subnet, that is a public subnet. What IP range I can pick? I can go here, I can pick this. So total 65,531 IP addresses. Which one? AP South 1 year. What is the name you want to give? You can give it. So this service endpoint we'll talk later. Just go here and click on create VPC. That's it. You are going to get a VPC. Click on create VPC. It is creating. Now VPC has been successfully created. Now we can start launching. But do you know how it got created? What are the resources or components it got created? What is the logic it is using? We don't know, right? But VPC created and it is available. And how many instances we can launch within that? See, we can launch 65,531. Why? Because you took only one. So that happens, right? So now I'm going to delete that VPC. Whenever you're deleting VPC, all subnets, internet gateway, everything deletes. Now, so the second wizard is VPC with a public subnet and private subnet. So a 16 network with 2/24 subnets, it is going to create. And it is even going to create a NAT. I'll talk about that. Click on select. So here is a CIDR block. What is a CIDR block? Now we need two subnets. One is a public subnet, another one is a private subnet. So now only one is not sufficient, right? What you need to do, divide it. So now we are getting two. But in future, if I want to create something, are we going to create any other subnet in future in the same VPC? If your answer is yes, don't go with the 2. Go with 4. Okay. So among these 4, pick 2, any of the 2. Okay. Go and get that here. Okay. So then go and pick this here. See, so total 65,531 IPs we are getting as we are using /16 for our entire VPC. For subnet 1, how many you are using? 16,000. So minus this. So again for private subnet, how many you are using? Again 16,000. If you don't want to, you decided to go with only 2, then go and give this 10.0.0.0/17 here, an error till you gave the second one, it's overlapping. See, 32,763, 32,763. Everything is consumed here itself. Do we have anything left for future usage? No, you cannot create any more subnet within this. So to not get into such type of limitations, we don't utilize full, we keep some. So now which subnet, which availability zone you want to treat it as a public? So AP South 1A, I want to treat as a public. AP South 1B, I want to treat as a private. Okay, so now this NAT concept I'll talk about the day after tomorrow. So then click on create VPC. Again, you are going to get a VPC. This is a VPC ID. This is a public subnet. This is a private subnet. Again, we don't know what exactly happening in backend. Right. So that is the second scenario. When coming to third one, public subnet, private subnet, but we are going to get a VPN connectivity. We are going to get a VPN, similar steps, but a VPN that enable communication between our on-premise to AWS. Of course, I'll talk about that one also. Private subnet with VPN connectivity. So these are the 4 scenarios we have. So VPC creation is not going to cost us anything, but don't create this NAT whenever you are giving. If you are generating elastic IP address, NAT gateway rates apply. So if you want to go and perform this VPC with a single public subnet, go and create this. Go and create this. It is not going to cost you anything. Okay. So remaining, like how we can create or segregate each and every step manually, that we will discuss tomorrow. So I hope this part is clear, whatever the basic things we discussed about the network and all, public IP address, private IP address, subnet and visual subnet calculator. This part is clear. So if you have any questions, we will discuss now.
Avinash, you said for maximum host IPs, right? We should go with /16, right?
Yes.
But why can't I use /8 when for a class A IP? Because there I was having 8 bits for network.
AWS won't support.
Okay, so probably I missed it. Okay,
Yeah.
fine.
AWS supports from /16 to /28 only. In
Okay.
your regular network, yes, you can do that, but within AWS, that's a limitation from AWS, not like not from me or like my VPC. It's a limit from AWS.
Okay, fine, thank you.
Avinash, can you pin that URL?
Yes, I added that in our document.
Okay.
Yeah. So, however, I'm going to add in our chat box also. You can just click on that link. So VPC is another very important topic in this course, guys. So please spare some time and please go through this. Just try to explore that visual subnet calculator and try to create one VPC with that wizard. So we will create that manually in our next session. Right? So that's it for today's session. See you again tomorrow. Thank you, guys.